Welcome, I'm Dr. Ronadavitan Sama. I'm your physics tutor for today. So I'll be introducing to you the topic, Introduction to Mechanics. And our lesson for today is Physical Quantities. Now, before we begin, I'd like us to look at some of these key terms. The first term is mechanics. What is mechanics all about? Mechanics in physics is simply the study of motion. Now, many of you will be asking, what about objects that are not in motion? Objects that are not in motion are motionless bodies. And that is a state of motion. Zero motion, it's a state of motion. And so those objects also are considered in the study of mechanics. Physical quantities. What are physical quantities? I'd like us to look at these two terms. Physical. Anything we can perceive with any of our senses. Smell, touch, feel, hear, and the rest. Those are physical elements. And therefore, any quantity that can be perceived with any of the five senses of the human body is what we are going to be considering in physics. Quantity. If any of these physical quantities we can perceive with our five senses can be and are measurable, then we consider those quantities physical quantities. So we are going to be looking at the first physical quantity, which will be what we will rely on in our lesson, and that physical quantity is a force. What is a force? A force, to me, I know all of us know of this definition. A force is a push or a pull. But I'd like to tell you of my own definition, which I feel is going to be broader than this, or no, not broader than this, but it engulfs this and is going to make more sense to me, is anything that is capable of changing the initial of a body. That's what I would like us to rely on. And I know many of us would like to ask ourselves, what is inertia? Inertia is the state of a body. So a body is either at rest or in motion. So it's very important for us to know, whenever we're talking about a physical property, what is the definition of that physical property we are talking about? What is the SI unit of that physical property we are talking about? How can we measure that physical property? So these are the three factors we are going to be looking at when we talk about force. We've already seen the definition of a force. Now, what could be the SI unit of a force? We know the Newton, actually, it's the name of the person who discovered the force, or who came out with the whole concept of the force, and that has been given the name the Newton. So another SI unit of a force is the kilogram meters per second square. So the third step of our study of the physical property, the force, is actually to know how to measure a force. I'm sorry, I was unable to have a scale balance, but actually the scale balance is a measuring instrument that we use to measure the mass of a body. But in coming out scientifically, in presenting an experiment, it's important for us to know the following stages of presentation. The first is for us to write the title of our experiment. The reason why the title of our experiment here is to measure a force. The second step is to find out what we require for our experiment. So the first thing we require for our experiment in measuring a force is the mass. A mass could be anything. So what is a mass also is a physical quantity, which is important for you to know. And it's more important to know that a mass is a base physical quantity. So one other lesson I'm going to be introducing is the difference between a base physical quantity and a derived physical quantity. But note that the mass of an object is a base physical quantity. Now the next thing we're going to need for us to measure the force is a scale balance, which is the instrument used to measure the mass of an object. Now, the next step is a setup. How are we going to set up our experiment in order to calculate the variables we need in our calculation? Now, consider that this is a scale balance. A scale balance is what most of us go to the market. Imagine Mami Gary or Mami Fish, who actually runs a small cold store in the main market. You go there to buy 1 kilogram or 2 kilograms of fish. She takes the fish and she puts on top of a scale pan and she measures the mass of that fish. So this is actually that scale pan, and we have the mass we want to measure. So this could be your fish, this could be your gari, it could be whatever thing you want to measure its mass. I'll just take for example here the mass of this tin of chocolate is 400 grams. So we could see the mass of our chocolate tin and its content is 400 grams. So grams is the SI unit of mass. And so we have here the mass of this. Imagine us calculating this. So we've calculated the mass to be 400 grams. Once we got our mass, it's important for us to know how the next step is the calculation. How can we get, we've gotten the variable, the mass, how can we get the force? Now, mathematically, we have a triangle and we have three physical properties on our triangles. F here stands for the force, M stands for the mass of the substance or whatever thing we are using, and A could stand here for the acceleration due to gravity. Now, I have put it this way for it to be very easy for us to convert from one formula to the other. Now, this horizontal line stands for division, and the vertical line stands for multiplication, such that it's easy for me to know if I want to calculate the force, it's going to be, the formula is going to be, I'm going to cover the force, and the formula will be the mass times the acceleration due to gravity. If I were looking for the mass, the formula, I'm going to write M, I cover the mass, and the formula is going to be the force divided by the acceleration due to gravity. And if I were asked to look for the acceleration due to gravity, I'm going to cover the acceleration due to gravity, and I'll be left with the force divided by the mass. And this, therefore, because we know that acceleration due to gravity we are assuming that the acceleration due to gravity for every mass that is found on the planet Earth, A is a constant, which is approximately 10 meters per second squared. It's constant on Earth, but if you go to another planet, it's going to have a different acceleration due to gravity, and therefore, since we've already known the mass of the object, and we know that the acceleration due to gravity on Earth is assumed to be approximately 10 meters per second squared, using the formula force is equal to mass times acceleration, we can be able to calculate the force of an object. As an exercise for you to take home, I would like you to, using this triangle, to tell me the number of physical quantities we have here, and try to look for ways of defining each of the physical quantities. In our next lesson, we are going to be looking at numerical applications of this formula. Thank you for always relying on O2 Academy for your education. See you next lesson.
Oh, that was more.
I'll grab that.
Mama, that's fine. We'll just do the rest of it. You know, why that good? But
In fact, they should have they had a course to stop.